Okay, so what I do have here is a number of lithium-ion battery packs from Ryobi. This one is 03-2009 and it doesn't work on the charger. When you put a voltmeter across it here, you'll see 5.84 volts, so it's discharged below its nominal 18 volts. You sort of like 12 volts and below that, they won't work on the chargers. I'll put a brief clip up for how this cell responds on the charger. You'll see the red light just keeps flashing and the charger doesn't switch over to charging mode, which is the green light flashing on this one. What else I have here is a number of these batteries, so it's pretty much similar age, 0209 on that one. And you'll see this one here, this does charge okay. And you'll see he's got full 20 volts there. And we'll have a look at another one. This one's 2012, 20 volts there. And then this one is 2016, 20.12 there. So those three are all okay. This one is faulty. What I'm going to do is drop these open and measure the actual AC impedance of the individual cells inside. So these are relatively easy to drop open. Screws underneath here are actually security screws, they're Torx, but there's no end of security bits around these days, so easy enough to get out. Save you having to drill out the security pin. So that's all the screws out, and then you usually have to have a little bit of a pry around. There's some clips on the inside usually just here that stop the case coming out completely, so they need a little bit of a pry open. You should just pry out hopefully. There we have the battery pack underneath. So I'll dismantle the other cells and then we can go along with the impedance tester and measure on the actual cells themselves. Go back on so we know which one it is. Okay, so we've turned the lights off, so hopefully you can see the screen on the iPad here, because as well as the Windows software that this unit has, it also has Bluetooth, which connects to an iOS device. This is the Gen X software from Hioki. This covers a lot of their instruments, one of which being the BT3554 battery series there. Obviously I've already had it connected, so there, I don't know how well you can see the screen. You can see it's connected to the battery, and I have it basically sitting there waiting for the readings. Then as I do the readings, it will automatically log those onto the screen. So we'll just zoom back out for this particular one. So before I do anything else, I will clear all of the memory. So if I go back to read, and I've got quite a lot of memory used on this from doing the tests at a site, and if I go clear, we'll clear the one reading, so that clears that one. Oops, not fast enough. So you'll see J11 now no longer has any data in it. Then you go 10, it goes back to 1. So 11 has no data. So that's one press of the clear button. If I press it twice, I will clear the whole of J. I'll do it fast enough. So now it goes back to existing readings, and I've got readings in obviously AO series. Let's go back there. I've got readings in B series, C series, D series, etc. To clear absolutely everything, I hit 1, 2, 3, clear all, enter. Now I've got no data whatsoever in the instrument. So what we'll do, this is the 0209, so this is a good battery. We'll go from top down to the bottom, and should be able to do all these 1, 2, 3, 4, 5 cells, hopefully. So 38.3 milliohms, 3.99 volts. Swap them over so we keep the polarities right. .96. Swap them again. 0.94. That's probably substantially higher. So my understanding of lithium ions is that as they age right at the very end, then you will see the resistance pick up. So I've got predominantly 32s on this one. Yeah, predominantly 32, 4.18. We've just got that one cell that goes up a little bit higher. Okay, so that's one good cell. It was a 2009, so this is a 2012 cell. Bring this around and zoom in on the iPad. Hopefully you'll see these readings come into this. So on B01, swap him again. So we get better voltages, slightly lower resistance, 28.2. Yeah, slightly lower on this one. So you look at a battery pack that's 3 years younger. 28.3 at 4.15. Okay, that's that one done. And we'll zoom back out into our instrument, and we'll go for the actual failed battery now. Before we do that, we'll just go memo, put him in memory bank C, and we will go for the same again. Obviously the voltages are going to be much lower on this unit, we hope. Yeah, 0.89 volts, but still 32.6 milliohms. Let's see what you're like. 1.38, there's a little bit more in that one. Oops. So resistance wise you'd say this wasn't too bad, but obviously the cells are extremely discharged, which I guess is the ultimate giveaway. .5, 2.77 volts on that one. Okay, so not an awful lot of difference in the resistance there. So what I'm going to do is I'm going to put this onto a slow charge and see if I can recover it and get it to work on the charger. And if I can, then I'll take another set of readings from it with Hioki for a comparison to see if the resistance has changed, whether it's recovered, but probably not, judging by the results I've got there. Okay, now I'll stick it onto a slow charge and we'll see what happens. To do this charge, I'm actually going to bypass the pack completely and charge the cells directly themselves just with a power supply, constant current source. So nothing special being done with that, but it should hopefully get these recovered because none of them are reading flat bank 0. So I'm assuming they're in reasonable condition, just not good enough for the actual Ryobi charger. Okay, so hopefully you can see this. I've just switched this on to slow trickle charge there. 50 milliamps we're putting in at the moment. As you see, I'm direct across the batteries here, and at the moment I'm on constant current so it will adjust the voltage to suit that constant current, and you can see it's come up to 9.6 volts and is rising reasonably rapidly. So as long as the cells don't overheat, which there should be no chance of that with it being on such a low current, that should be fine. And then when we've got it charged up, we'll see what happens impedance wise. Okay, so we have had our battery on charge for a few hours and we've managed to lift the voltage up. So we are now at 18.47 volts on the outgoing terminals here. So hopefully this will go onto charge. You can see the red light flashing away there, and there it goes onto green. So that's now indicating that it is charging, so hopefully that will give it a full charge, and then once it's finished that, we'll remeasure the battery impedance with the BT3554. Okay, so we're going to go through remeasuring the AC resistance of the battery pack. This time, just for a treat, I'm going to actually hit the start button on the iPad, so it should then actually record the data, unlike last time when somebody didn't hit the record button. Okay, so first cell. Ooh. What's going on there? There we go. Okay, that's the first measurement. Oh, let's have a little ping while it's doing it. Okay. You can see every time I'm doing that, the recorded data goes up and back that way. Reversed again. And the final one. Okay, so that should have saved all of those. Battery data has been saved. Okay, so all the readings have been saved. This is the data list from previous readings that I've made. I have noticed because the software on this is for all their instruments, you get readings from any instrument. So there's some readings from an insulation tester that I did, and these are the battery ones that I did. I've renamed this top one Ryobi as the one that I saved while doing the retests with the BT3554. You can click on the actual data block itself and it takes you to a mini report of the readings that it's made. There's the actual list of each individual cell, time and date stamped, and then milliohms and the actual voltage. So you see the voltage is actually up quite well across them, and the resistance is relatively consistent. Maybe 25, 26 is a little bit higher. Okay, so as well as the list, you can go to chart. On this, you can actually click on and put a up here. Then it tells you the actual value that you had, so you can go along, find each one. It's on resistance. You can change it to voltage as well. And there's my voltage, and you can see pretty level across all 5 cells really. Final tab over here is threshold. I didn't enter those values, so there's nothing saved in there. I'll probably do a retest on one of the other ones and use this functionality and show that in a different video. So if you go obviously down here at the very bottom as well, you have the option if you want to, it's got to resistance. You can save the screenshot, and then that suits you. Obviously you can do this internally within the iOS anyway by using the top button and the touch control down there, but it's got a built-in save screen as well. And then to get a report out, if I actually highlight it up there, create report, Correct here. And then you can change these to whatever you like. Click the OK. And then it's done the report. OK. And then again, just tap that, and then you can scroll through, creates a little PDF. And there's my graph of my resistance there. That's what it saved. Oh, that's a battery screenshot. Beg your pardon. Okay, so in the report, you've got here, you've got pass, warning and fails. You've got the actual readings that were made. And then the graph hasn't come out very well down there, has it? So same with the voltage as well. Temperature, there was no temperature readings taken, so that's blanked. And then any comments that you want to add. So to be honest, I don't think I'd use this for reporting. I think I'd use it just to send the data to a computer if I was going to use it. But the machine works pretty well, just saving the data and then exporting USB to Windows PC. Okay, so to compare it to previous tests when the battery was discharged, I'll need to take another look at the instrument because I didn't save those readings to the iPad. This a little bit better. If we go back through memory, we've got 26.9, so the voltage is up this time. 30.2, 26. Yeah, so sort of 25 to 30 now that it's all charged up on the AC resistance. Prior to that, let's go back to read. It was on cell C. So cell 1. So yeah, 31, 32, 32. Okay, so probably fractionally higher when it was discharged, but nothing that you would say would stand out significantly to tell you that the AC resistance is telling you the 18650 cell is faulty. So what I'll do is download this to the computer, and I'll leave you with a table / plot of the measurements so you can compare them for yourselves. That's pretty much it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next video.